Alright guys, day 2 here, unit 13. We're going to look to see what the greatest common factor is in order to factor these. So for number 17 here, we have 3x squared plus 9x. So we're looking for a common factor that we see in 3x squared and in 9x that we can pull out or divide out in front. So first thing I look at are the numbers. Is there a number that goes into 3 and 9? Well, yeah, 3. So 3 is my GCF for my number part of it. And then, is there a variable that I can pull out as well? Here I have x squared, which means I really have two x's sitting over here. And with this 9x, I have another x sitting over here. So how many are in common? We have an x on this side and an x in here. So my common factor of the x's is just an x. Alright, so my GCF of 3x squared plus 9x is 3x. That's what we need to do first before we actually factor it. I messed that up. Alright, we'll do that again. Alright, so 3x. And then what I'm going to do is ask myself, what can I multiply by 3x to give me this original term here, 3x squared? Well, 3x times 1x will give me 3x squared. And then I have a positive sign. 3x times what will give me my 9x. 3 times 3 is 9. And then when I do 3x times 3, that gives me my 9x, because 3x times 3 is 9x.
Alright guys, for practice problem number 18, I'm just going to shoot it over here and kind of zoom in. So what I like to do, and you guys have seen me do this in class, is I like to write just over to the side what the GCF is. So GCF equals, and I take a look at my numbers first. So what number can go into both 8 and 20? And, this is from, I think, 5th and 6th grade. What two numbers can I multiply together to get 8? What two numbers can I multiply together to get 20? And what's the largest number that they share? And the largest number that they share is 4. 4 can go into both 8 and 20 evenly. And now I look at my variables. Do they both share a variable? And they do. And like Mr. Gallant pointed out in the last problem, x squared is really x times x. So they at least share one x together. So my GCF is going to be 4x. So to set this up, I'm going to put my 4x, and then the hard part that I see for a lot of students is what goes in that parentheses. And I usually like to do this over off to the side. So essentially what I'm doing is I'm taking my problem, 8x squared minus 20x, and I'm dividing it by my GCF. And then this is exactly what we did in Unit 1. Alright, so how many times can 4 go into 8? 4 can go into 8 twice. Alright, what's the rule for dividing exponents? We're going to subtract them, right, because there's an invisible 1 right there, so that's going to remain 2x to the first power. And then how many times does 4 go into negative 20? That goes in there negative 5 times. And what happens with our x's? Well, we have invisible 1 minus an invisible 1. It's x to the 0 power, and just a refresher, anything to the 0 power is 1. 1 times 20, I'm sorry, 1 times 5 is 5, so you just leave it 5.
Alright, we can show you one more here because the last two are very similar. We're looking for a GCF for number 19 here that goes into all three of these terms this time. So what goes into 3x squared, a negative 9x, and a 27? First thing I notice is there's not an x with this 27, so there's no x in common. You can't have an x in common if it's not listed in all three of these terms. So we're just looking for the GCF of 3, 9, and 27, which is 3. And then we're going to do what Mr. Wells did there. We're going to divide all three of these terms here by 3. 3x squared divided by 3 is x squared. 9 divided by 3 would be 3x. And then 27 divided by 3 would be 9.